Hi everybody, Mary here, and welcome to Chapter 9. Chapter 9 is all about torque and center of gravity. Now, torque is defined as a force that is applied some distance from a lever arm. So torque is used to make things rotate or stop rotating. Torques are applied every time you turn a doorknob or you use a screwdriver to pry open a paint can. You use torques on a daily basis when you're driving your car or anytime there is a rotation or something tips over. I believe the math for this chapter is not too bad and that you're going to have some fun with it, and the lab is, I think, a lot of fun. But, you know, I'm crazy. I like all my labs. So let's go forth and take a look at the chapter. So we're going to talk about torque and center of gravity. Of course, we're going to have a study guide, some homework problems, not too bad. We only have 9 of those. We're going to spend some time talking about simple machines. Simple machines have been around for a very long time. These are everything from screws, levers, inclined planes, pulley systems, and I've got some fun videos that hopefully will be fun for you to watch about those different kinds of simple machines. After those, of course, there is going to be discussion about center of gravity, which is the place where the mathematical place we can pretend the mass of an object exists. Every time that we've had a sum the force problem and we've put a dot there, we've been putting that on the CG. Static equilibrium is one kind of torque problems, and then we're going to go to our torque and CG lab. So let's talk a little bit about that torque and CG lab. This lab, you are going to do 2 things. You're going to find the center of gravity of a marble snowman, and then you're going to build some structures and some of the torques on them. So let's talk about this marble snowman first off. When I do this lab in a face-to-face class, I have students calculate their center of gravity. And we do this by having 2 bathroom scales, bathroom scale here, bathroom scale there, a big wooden plank, and have a student lay so that his or her head is on one end of the plank. We read the foot weight on the foot end of the scale, and we use a variety of information to calculate the center of mass of this person. Well, you probably don't have 2 bathroom scales and a big piece of lumber around your house, so you are going to construct a little snowman out of your acrylic ball, steel ball, and the little marble in your kit, and you're going to use your little ruler instead of that plank. You're going to use a collection of 7 washers for one end, and this end is just to support the structure and keep it level. The other end you're going to place on your electronic balance. And notice you only want a tiny, tiny bit of this ruler on that balance. The least amount possible so that you can still get a reading is the best way to do this. You're going to mass everything. To mass your snowman, notice you even use the clay that you use to stick them to the ruler. You put that on the balance, you get the entire mass. The head of the snowman is going to be flush with the head of the ruler. And I give you some positions so that everybody has pretty much the same positions of the masses on the ruler, so we get all real similar results. And you set this up, take some data readings, and then you're going to calculate the CG. Big hint is in the example problems, we have an example problem that is pretty much identical to this. So as you're doing the math for this, please look through the example problems. For the second part of the lab, you are going to create a Teeter-Totter system. To do that, you're going to take your big metal bar, put some tick marks on it using the metric or centimeter side of your measuring tape. And then you're going to take your clay and build kind of a fulcrum out of that with the clay. Now, please do not wedge the metal bar into the clay so that it can't move. This metal bar has to be able to swing and rotate back and forth. Now, your metal bar is exactly 36 inches long, but it is not going to have a center at a nice even metric number because the metal bar is a English unit of measure long. You are then going to hang some weights in it, and you're going to do the math, and you are going to build it to where you add additional weights to make the whole system balance. The weights you're going to add are going to be your large and small metal washers. These are the ones you are going to use for the lab. Add some string to these washers so you can hang them on the metal bar. and then mass these because you're going to reuse this set of washers for your various setups. You also will need the mass of the metal bar all by itself. Then you are going to build 3 setups with the metal bar, and then you're going to put the washers and string at various locations, and then you're going to calculate where to add one additional weight or collection of weights, in this case, where to place 3 large washers, and they're all going to be in one little bundle. Where you're going to place them, obviously over here someplace. You're going to calculate that position, and then you're going to build that setup like I built this one. And notice I didn't photograph the other half of it. And then you're going to compare the mathematics, where mathematics said that should be located versus when you take a photo of the balance system, and you're going to compare how many centimeters difference between the calculated and the actual physical location. Then I'm going to ask you to build 2 more complicated setups. We're going to move that fulcrum, put a couple weights on, add this time 1 large washer, and where should it go in order to balance? You're going to do the math, build it, include a photo, and then for the last setup, you're going to build a much more complicated system, and you're going to calculate where to add your collection of 3 large washers. You're going to, again, do the math, then build it and add a photo. So this lab, the math is not terribly difficult. It is a little bit futzy. It takes a little bit of time to get everything in place. Don't hurt yourself trying to make sure that everything is perfectly level. If things are pretty much level, life is pretty darn good. So that should do it for this week. At the end of this chapter, we're going to have one joint test for both chapters 8 and 9. That will cover all of momentum and torque. So have a super duper week, and we will talk to you soon. As always, please reach out if you have some questions. All right, see ya. Bye.